Okay, I haven't got much time to do this one, so you might want to pause the video to look at the working in a bit more detail and to go back and reread the question, or maybe print out the question so that you've got that in front of you while you're looking at the solutions. So this is a question, another hypothesis testing question about a coffee shop and how many of its customers are accessing the internet. So we're giving the probability that a customer is accessing the internet is 0.35, and we're going to be looking for some various probabilities and then do a hypothesis test and then another hypothesis test. So in the first part, we have got a binomial distribution. We had n is 10 and p is 0.35. And we're looking first of all for the probability that there are 5 customers accessing the internet. So probability x equals 5. We just use the NCR formula. So 10c 5, 0.35 to the 5, 0.65 to the 5, and you can work that out on your calculator. For the next part, we've got an inequality. So we're looking for the probability that x is greater than or equal to 5. I like to draw a little number line, so here's the 5, the numbers either side are 4 and 6. So being greater than or equal to 5 is 1 minus x is less than or equal to 4. I can look up that value on the tables and give my final answer there. And then it was asking for the expected value, so the expectation of x is np, which is just 10 multiplied by 0.35, so that's 3.5 customers. Moving on to the hypothesis test then, in the question it says that we're testing to see whether this other coffee shop has got a probability that's different from 0.35. So they're not saying that it's less than or more than, it's just different from, so we're going to use a not equal to in the alternative hypothesis. The question asked to say a reason for our choice of alternative hypothesis, so we'll need to write something about the fact we've used a not equal to here because it said different from in the question. And we need to state what P is, the probability of a customer accessing the internet in the coffee shop in the population. Now, this is a two-tail test then, and it's at the 5% significance level. So we split the 5% to put 2.5% at the small end and 2.5% at the big end. Now, the expected value in this case is 20 multiplied by 0.35, so that's 7. So we'd expect 7. The result that we actually get is 10. So it's not possible, since we're expecting 7, 10 is more than what we expect, so it might be in this end. It's not possible for it to be in this end. So we're looking to see if...
Thank you, miss.
So we're looking to see if the value of 10 is in this top bit or not. So using the table, starting from this bit in the middle, we're looking for 97.5%, because 1 minus 97.5% will be 2.5%. So we've got one that's a bit below 97.5, one that's a bit above 97.5. So we can work back through the tables. We've got less than or equal to 10, less than or equal to 11. Using this same number line idea, 1 minus less than or equal to 10 gives us 11 or more, and 1 minus less than or equal to 11 gives us 12 or more. So this is the bit we're interested in really then, and 11 and 12 are our boundary lines. Our critical value is 12, so the result of 10 does not lie in the critical region, so that's not significant. We're going to accept H0 for this part of the question. There is not sufficient evidence to suggest that the probability for customers in this coffee shop accessing the internet is different from 0.35. Finally, we have a larger sample, so we've got n is 200, so we're hoping not to have to do the calculations ourselves because the tables only go up to 20, but they've given us some results. So the result they gave us was that the probability of being greater than or equal to 90 was 0.0022, so that's 0.22%. Now, we need to know whether that's in the critical region. Well, if that bit's only 0.22%, the critical region is the bit that's 2.5%. So since this is smaller than 2.5%, and 90 must be over here within the critical region. So x is 90 is in the critical region, therefore the result is significant now, so we reject H0, and we'll say there is sufficient evidence to suggest the exact same thing that we put in the previous part of the answer.